So what happens to solar energy from the sun? So some of the energy is going to be absorbed by the object, that being the Earth. Some substances, such as water and air, are transparent to certain wavelengths of radiation. And then some of the radiation is going to bounce off the object without being absorbed. So this shows us visually what happens to a lot of the radiation. We have 100% solar radiation coming in. 51% of it is going to be absorbed by the surface of the Earth. 4% of it is going to be reflected off the surface of the Earth back into space. 20% of that radiation is reflected by the top of clouds back into space. 6% is reflected by the actual atmosphere back into space, and then 19% absorbed by the atmosphere and in clouds. So again, this just pretty much goes over what I just talked about from the last image. We want to make sure to note that the greenhouse effect here is important. We have re-radiation of thermal energy off the Earth back into the atmosphere, but then the atmosphere reflects it back onto the Earth, creating this back and forth where the Earth is able to hold on to some of that warmth, some of that radiant energy. So why do temperatures vary so much between one location on Earth to another location? Some important factors here are going to be the latitude of the location, water, altitude of location, cloud coverage, and ocean currents. So starting with latitude. Latitude is the angular distance of a place north or south of the equator. And radiation tends to hit the equator more directly, and therefore the radiation is more intense at the equator. Radiation that hits the poles is indirect, kind of like a glancing blow. It's going to hit it at an angle, and it's going to cover a greater area for the same amount of radiation. We can see that visually here. A, B, and C, all three of those show the same amount of radiation, but you can see as we get closer to the pole, all of that radiation gets more spread out. If we look at A, it's a direct hit at the equator, so all that energy is focused in on a much smaller area. Again, this is just showing that the angle that this radiation hits the Earth is going to make it so that radiant energy is spread out more towards the poles than it is at the equator. And I just want to come back to this image. This shows us exactly what that looks like. We have really high intensity radiation at the equator and really low intensity radiation at the poles, and somewhere in between values from the equator to each pole. Land and water also play a key factor when it comes to climate and weather. So heating of Earth's surface controls the temperature of the air above it, and different land surfaces absorb varying solar energy. So you can oftentimes, if you walk on a blacktop without any shoes on, it's a lot hotter than if you were to walk on grass. But the biggest difference between absorbed energy is going to be between land and water. Land heats up more rapidly and to a higher temperature than water, and then also cools off more rapidly and to a lower temperature than water. Water doesn't vary very much in its temperature. So the largest temperature variation is going to occur on land, specifically land that is not all that close to water. Land near water, like California, is going to not vary in its high and low temperatures because of the ocean being right there, regulating its temperature. Altitude is also going to affect it. So think of Phoenix versus Flagstaff. Phoenix is only 1,086 feet above sea level and experiences an average temperature of 74 degrees Fahrenheit midday high in the winter, while Flagstaff is near 7,000 feet above sea level and it experiences an average of 49 degrees during the winter as well. So the higher the altitude, it's going to lower the temperature, and it's also going to create more cloud formation. So Flagstaff, because of its altitude, is going to experience more storms, more rain, more precipitation.